this material is the beginning of Unit 2 material. And the first topic that we're looking at in Unit 2 is a topic on chemical bonding. Now at this point, my lecture is being geared for both my Chem 2A and my Chem 22 students. So 2A students, it's going to be very helpful if you have your textbooks with you right at this moment and open to Chapter 6 of the textbook. Chem 22 students, your textbook with you right now and open to Chapter 10 of the textbook. Both of these chapters are discussing introducing chemical bonding to you. And we're really beginning to get a deeper understanding of what chemistry is all about. Why do chemical reactions occur? What's driving them, causing them to happen? So as I put up on the board, all chemical reactions involve the breaking of bonds in reactant substances and the formation of new bonds in the products that are formed from the reaction. Right? So change is happening. Atoms are breaking their bonding arrangement that they are in as reactants. Rearrangement is going on. And then we have new chemical bonds being formed as products are forming. This is all being driven by the Octet Rule. And we're going to talk a lot about the Octet Rule. So what does the Octet Rule state? It states that atoms will react to either gain electrons or lose electrons or share electrons to obtain 8 valence electrons in their outermost valence energy level. And I should state here, this is an either or, so to either gain electrons, lose electrons, or share electrons to obtain 8 valence electrons in their outermost or valence energy level. And you know that configuration of 8 valence electrons is associated with the noble gas configuration, and that is a very stable electron configuration and explains why the noble gases as a family are very unreactive. They've achieved that octet, that set of 8 electrons in their valence energy level. Now, before we can go into a deeper understanding of bonding, we're going to have some notation, some symbols that can help us focus more clearly on it, because it's those valence electrons that we're most interested in studying. So you can find this information either in Chem 2A, Chapter 4, Section 4.8, or Chem 22, Chapter 10, Section 10.2. It's a notation that's very useful, chemists use, to focus on these valence electrons. So you see here that I have notations for representative families, 1A through 8A. And you know that those Roman numerals 1, 2, 3, so on, all the way through 8 are indications of how many valence electrons all the elements in that family have. So we can use symbols to help us clearly see that. So notice with family 1A, the alkali metals, they all have 1 valence electron, hence the Roman numeral 1A. And I am showing sodium with 1 valence electron. I'm using a dot to symbolize that electron. And then I'm showing potassium with a valence electron. Notice I changed the symbols from dot to an X. Doesn't matter whether you use a dot or an X, whatever is most comfortable to you. I'll often use X's because I find I can write those faster on the whiteboard. So the important thing is that for the element, you show the correct number of valence electrons that it has in its outermost energy level, and that correlates to the group number for the representative families, the A families. It's also, by convention, a place where we position the valence electrons using the points of the compass. So east, north, west, south, as long as you use the points of the compass. You would never want to use the corners. For example, if you gave some symbol here and you put an electron with an X in the upper right-hand corner, I'm confused because that upper right-hand corner is where we place charge on an atom if it has one. Likewise, if you put an electron here in the upper left corner, I'm confused because that's where we put mass number, and likewise in the lower left-hand corner, atomic number. So you do not want to use anything other than the points of the compass, north, south, east, west. So real quickly, we're just going through here. Alkali metals, 1 valence electron. Doesn't matter where you position it using the points of the compass as long as you're showing 1 electron. Alkaline earth metals, family 2A, 2 valence electrons. So here is magnesium with 2 valence electrons, and calcium, also an alkaline earth metal. Notice I split those 2 electrons up and put them on opposite sides. Totally fine to do that as long as you're showing the correct number of electrons. Aluminum in family 3A with 3 valence electrons. I could have also shown aluminum using X's and split those 3 electrons apart, no problem, as long as I have the correct number. Continuing through, I think you see the pattern here for family 6A, the oxygen family, placing 6 valence electrons around oxygen, or I could have used dots and split some of those electrons up, no problem. Family 7A, the halogen family, here's fluorine with 7 valence electrons. Would have been fine to use X's for that. And then lastly, the noble gas family with that octet of 8 valence electrons. Here's neon with 8 electrons around it. Please be aware that helium, although it is a noble gas element, cannot have 8 valence electrons because it only has 2 electrons total. So helium follows what we call the Duet Rule. Its goal is to have 2 valence electrons in its outermost energy level, which is the first energy level, because that's the maximum number of electrons that the first energy level can hold. Remember, it only has an s orbital in that first energy level that can hold only 2 electrons. So both hydrogen and helium are period 1 elements. Both follow the Duet Rule, not the Octet Rule. And we'll be reminding you of that as we continue through these lectures.